Hello everyone, and in this lesson we are looking at section 4.3, which focuses on rotations. So what a rotation is, it's a transformation in which a figure is turned about a fixed point. In this figure over here, we have our pre-image, which is this line RQ, or it's this whole flag, sorry, with an endpoint R and an endpoint Q. And it's rotating about this fixed point P. So we're taking this image and we're going to rotate it about that point P. That point P is known as the center of rotation, the fixed point in a rotation. And then how far the picture rotates, or the object rotates, is known as the angle of rotation. So the angle that is formed by rays drawn from the center of the rotation to a point and its image is known as the angle of rotation. Rotations are a rigid motion, or isometric, so what that means is they are not going to change size or shape. All of the angles and side lengths are going to stay the same. When we talk rotation, we talk about direction. We have to indicate which way we're going. We like to say that we are going clockwise or counterclockwise. When we talk clockwise rotations, in the world of rotation, this is a negative rotation. And counterclockwise is actually our positive direction, which is opposite what we think because it's going backwards on the clock, which we read every single day. So let's do an example. And with this example, we're actually going to learn about constructions and how to construct an angle of rotation. So in this one, it says construct a 75-degree rotation of triangle ABC about point P. So in the book that I am referencing, it's from Big Ideas, and a lot of the times they don't talk about which direction. So if there's no direction indicated, we are going to work with the counterclockwise, that's supposed to be one word, counterclockwise direction, which again, that's our positive direction. Counterclockwise is positive, so if there's no negative indicated, we always want the positive, so we'll go counterclockwise. So for here, construct a 75-degree rotation, which no direction is indicated, so we are going to go in the counterclockwise direction. I put a snippet of directions with pictures here as to how to construct a rotation of a specific degree. I do things slightly different, not a whole lot different, so I'm going to show you my way, and you can read this way. But the first thing is exactly the same. We want to connect our vertices of our figure to our point of rotation. So I'm going to draw a line first from A to our point of rotation, P. And then part 2 is really similar too. I do the exact same thing here. So now I want to measure the angle that I want to rotate. So I want to rotate 75 degrees in the counterclockwise direction. So counterclockwise is this direction. So that's the direction we want all of our points to go. So I'm going to line up my 0 point on point P. Then I'm going to measure 75 degrees from there. 75 degrees is an acute angle, so I'm going to work with these bottom numbers here. And it is going to be right here. Now I'm going to draw a line from P to that little tick mark that I made out there. And this is a 75-degree angle. This is where my directions differ a little bit. I don't have you measure. What I have you do is have you draw an arc. This is how I want my students to do it. We're going to take our compass and we're going to put its stationary point on the point of rotation and measure to the vertice that we just drew an angle from. So we're at point A, and I'm going to draw an arc. Let me straighten this paper out. Draw an arc from A to that line that we just drew of 75 degrees. And where that intersects, this is A prime. So this is point A rotated counterclockwise 75 degrees. We're going to repeat the process for every single point on our figure. The more points, the more time it's going to take, and it's just a process. I always draw one line from a vertex to the point at a time so that I don't get my lines all mixed up, because if you have a shape that has quite a few vertices on it, it's easy to mix up which line you're working with. So again, drew a line from point B to point P, lined up my compass on my 0, and then I'm measuring to 75 degrees, drawing that line. I'm going to take my compass, expand it so that I have that distance from point P to point B, and I will draw an arc. So this was my B prime arc, so the intersection point is here. Now we have to do this one more time because we are working with C. If you have the ability to change colors in your compass, that would be beneficial, especially if you have a lot of points, because everything is all gray for me right now, and it's easy to mix up. So again, 75 degrees from C to this C prime line, and now I have to take my compass, shrink it down so that my radius is from point C, or I'm sorry, from point P to point C. And then I draw my arc. Oops, that's a little bit small. Draw my arc to that C prime line. Intersection point is C prime. And now what we're going to do is connect A prime, B prime, C prime. That will be our rotated gear. Instructions. Fortunately, anytime you're given something on an axis or something with coordinate points, and you have a rotation of 90 degrees, 180 degrees, or 270 degrees, you can apply a rule. So these rules are similar to those that we learned in the lines of reflection. You're given an original point, rotation about 90 degrees, you switch your x and y's and you take the opposite sign of your y. Rotation of 180 degrees, keep your x and y's in the same position but take the opposite signs. And rotation of 270 degrees, take your x and y, switch positions, keep the same sign of the y, and take the opposite sign of the x. So let's go ahead and do an example. So we have triangle DEF, and it's located on a coordinate system. So we want to rotate it 180 degrees and draw that rotated image. 180 degree rotation has the rule XY yields negative x, negative y. So we just take the opposite sign of each of our x and y for the coordinate point. So if we are first looking at point D is left 4, up 1. Taking the opposite sign of 4 is, opposite sign of negative 4 is positive 4. And opposite sign of positive 1 is negative 1, so that will give us D prime. E is to the right 1 and up 4. So E prime, take the opposite signs, we get negative 1, negative 4. And F has the coordinate point to the right 2, down 2. So F prime will be negative 2, positive 2. Let's go ahead and plot these. So we are plotting these 3 points right here. D prime has the point to the right 4, down 1. E prime is left 1, down 4. And F prime is left 2, up 2. Connect our points using a straight edge. And our figure looks like this. It also says to confirm the rotation with Paddy paper. So grab a piece of Paddy paper and trace your original image on there. D, point E, point F, 3 sides of the triangle. The next thing we want to do after we trace the figure is we need a set of crosshairs in the middle here. So just trace part of your XY axes. And this will allow us to see how far we have gone once we've hit 180 degrees. So we are starting, I'm going to start looking up here where I put this X, and we're going to rotate in the positive direction 180 degrees. So I want to wait until this X is all the way down here. So I'm going to put my pencil in the center of my crosshairs and rotate. And as you watch these crosshairs, we'll be able to tell once we've hit 90 degrees. So this would be a 90-degree rotation right here. So we keep going another 90, watching that crosshair, and we get 180 degrees right there. And we can see that we did that right. So this is a quick way to double check that you did this right, because if one of your points are off, like if we had actually done 4, instead of going down 1, we went up 1, we'd have our point D prime right there. So we would be able to see quickly that we did this incorrectly. The last bit of information that this section covers is rotational symmetry. So we're talking about rotation, and when we talk symmetry, that means we have a reflection of the exact same thing, but in this case we're rotating it. When a figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure, and then the center of the rotation is the fixed point in a rotation. So if you take a look here, the center of this pinwheel is our center of rotation, and then it has multiple rotational symmetries because of the way this is set up. If we take this pinwheel and we rotate it in the positive direction, we have the exact same setup when we rotate it 90 degrees, and then when we rotate it 180 degrees. So these two figures look exactly the same as the original, and they're 180 degrees or less. So there are 2 sets of rotational symmetry for this. Some examples we have down here. We have an equilateral triangle, scalene triangle, and then this 1, 2, 3, 4, 5, 6 hexagon. And if you're ever unsure, trace your shape, approximate the middle, and then rotate it. Also, draw on the crosshairs so you can see how far you've rotated. This is my starting point up here. If I rotate 90 degrees, I'm not matching back up. But if I keep going a little bit more, well, my center was slightly off, I line back up. And this slightly more, sometimes it's hard to figure out. But because it's a 3-sided figure, if you take 360 and divide it by 3, because a full circle's 360, we get 120 degrees. So this has rotational symmetry of 120 degrees. And the next time we meet back up to have this same figure, we're going to have rotated 240 degrees, which is more than 180 degrees. So there is one set of rotational symmetry, so yes, and it's 1. Because the second time we hit the exact same figure, we're over that 180 degree mark. If we look at the scalene triangle here, trace that. We're going to have to approximate where that center is. Sometimes they're really hard to figure out. But if we approximate the center of this scalene triangle is here, let's put in some crosshairs and see if we can line this back up within 180 degrees. So when this dot is down here at the bottom, if we keep rotating, we're not matching up, not matching up, not matching up. So we've rotated 180 degrees, and our figure does not look the exact same as it did. So there is no rotational symmetry in this. And then finally, if we take a look at this last figure, trace this, approximate that middle point, because they're not telling us where the middle is, Put your crosshairs there, put your pencil in the center, and keep rotating. So right now we have rotated 90 degrees, and we do not have the exact same figure back. So let's try rotating a little bit further. And once we hit that 180 degree mark, if we found the exact center, it would line right back up. But we are back to that original shape. So this one does have rotational symmetry. I don't know why I'm writing 1. I apologize. And it's 180 degrees. And this one here should be 120 degrees, not 1. So that does it for this lesson on section 4.3, which is on rotation. So we defined a rotation and then the directions of rotation. We learned how to construct a rotation of a given degree, learned about the coordinate rules for rotation, and then the lines of rotational symmetry. Thank you for listening, and I will talk to you soon.